We're going to be talking about dimensional analysis. Now, dimensional analysis is going to be a process that we use in science to help us convert between different units. Now, for chemistry, what we're really going to be looking at for this is going to be converting our grams of our reactants to the grams of the products, or essentially trying to figure out how much of a product we're able to make given what we have. Now, in dimensional analysis, this is also known as the diagonal rule, because we're going to be looking at different conversions in order to cancel out the units. So we're first going to take a look at the conversion between 1,000 meters and 1 kilometer. So our conversion is able to be looked at two different ways. So we have 1 kilometer can be over 1,000 meters, or we could do it as 1,000 meters over 1 kilometer. So both of these represent the conversion factor that relates 1 kilometer to 1,000 meters. And we're able to use either of these depending on which way we want to go. Now, we use the conversion factor in dimensional analysis to cancel out a unit and introduce a new unit. So if we take a look at that kilometer, so if we have 4 kilometers or 48 kilometers, we can then multiply by 1,000 meters over 1 kilometer. The kilometers will essentially be canceled out, leaving us only with our meters. And the meters is going to be what we want to find from it. Let's go ahead and take a look at an example. All right, so we're looking at 358.3 inches, converting those to feet. So we are going to start with our 358.3 inches on top. Now, in dimensional analysis, we do put it into a chart form. And how we're going to look at this is going to be, we have inches on top. So that means that we have to have inches on the diagonal. Now, if we remember that there are going to be 12 inches equal to 1 foot. So this will be the conversion factor that we're able to use. So our 12 inches will be equal to our 1 foot. And if we look, we're able to see that the conversion of inches will cancel, leaving us with feet, which is what we're trying to find. So we are able to go ahead and we're able to solve. Now, how we're able to solve this is by multiplying the top, multiplying the bottom, and then dividing. So in this case, we get 358.3 times 1 being 358.3, and then we're going to divide it by 12. Whenever we do this, what we get as our answer is 29.86 feet. And so we have converted from inches to feet. Looking at our next example is that we want to convert the answer from our previous question into yards. So our answer from our previous question was 29.86 feet. So starting with that number, we have 29.86 feet. We're going to put it into our chart, remembering that feet will be the same on the diagonal. And then if we remember our conversion, we have 3 feet is equal to 1 yard. So our 3 feet will be on this diagonal, equal to 1 yard. Now that we are in yards, we're able to go ahead and solve this problem. We're going to multiply the top, multiply the bottom, and then divide. So we are going to get 29.86 times 1 divided by 3. Whenever we solve this out, we end up with 9.953 yards as the answer. Taking a look at our next one, we're going to convert the 358.3 inches directly into yards. So we're essentially going to combine the last two problems that we did together. We have 358.3 58.3 inches. Our inches are going to be on top, so we know that we're going to have inches on the diagonal, and this is going to be our 12 inches, being equal to 1 foot. Now, what we do in order to continue this is that we just expand this chart one more time. Now that we have feet on top, we can cancel out feet on this next diagonal, and we have 3 feet being equal to 1 yard. And now that we have all that, we're able to solve. We're going to multiply everything on top, multiply everything on the bottom, and then we're going to divide. So we're going to get 358.3 times 1 times 1 being 358.3 divided by 12 times 3, which will be 36. Dividing those numbers, what we end up getting is going to be our 9.953 yards. So we end up with the same answer, but this way it's a little bit more direct because we're able to have that in just a single problem and not split it up. Let's go ahead and take a look at a little bit more of an odd situation. So in this example, it's asking us that before the use of money, people bartered for goods that they needed. If 25 chickens could be traded for 1 pig, 10 pigs could be traded for 1 cow, and 2 cows could be traded for 3 horses, how many horses can be exchanged for 1,500 chickens? So looking at this question, we are going to be starting with our 1,500 chickens because that's what we're going to be bartering with. So we have our 1,500 chickens. Setting this up in our chart, we have chickens on top, which means that on the diagonal, we're going to also need to have chickens. Now, if we look at the conversion factors that this gives us, it's saying that 25 chickens can be traded for 1 pig. So now and everything, our chickens are able to cancel. We are left with pigs, but we need to continue this in order to convert our pigs over to our cows next. So we have our 1 pig on top. So our pig will be on our next diagonal. From the conversion that it provides us, it says that 10 pigs can be traded for 1 cow. Now that we are in cows, we are able to do one more conversion to convert the cows over to horses. And we're going to expand this just one more time. Same process. We have cow on top, which means that we're going to have cow on the diagonal. Now, this last conversion, it tells us that we have 2 cows can be traded for 3 horses. And we're able to solve. We're going to multiply everything on top, multiply everything on the bottom, and then we're going to divide. So we are going to end up with 1,500 chickens times our 3 horses. So we end up with 4,500 divided by everything multiplied on the bottom. So 25 times 10 times 2, which will be 500. Dividing these, what we'll end up with is going to be 9 horses. So by using this dimensional analysis, we're able to convert our 1,500 chickens over into horses. Let's go ahead and take a look at the next example. So we want to convert 500 grams to ounces if 1 pound is equal to 454 grams and 16 ounces is equal to 1 pound. So getting a little bit more scientific with this, with the grams and pounds and ounces. So we're starting off with our 500 grams, converting this over. Exact same process. We have grams on top, so we need to know that we have grams on this diagonal. This will be our 454 grams. That's equal to 1 pound. Continuing this process, because we want to go to ounces, we're going to expand this. We have our pounds on top, so we know that we're going to have pounds on the diagonal. Looking at our conversion, it says that our 1 pound will be equal to 16 ounces. Now that we're in ounces, we're able to solve. We're going to multiply the top, multiply the bottom, and then we are going to divide. So we are going to get our 500 times 16 will be 8,000 divided by 454 times 1. Dividing those, we'll end up with 17.6 ounces. Now, our 17.6 ounces is still adhering to the number of significant figures. So if we take a look at our 500, because of this decimal point, this has 3 significant figures, which means that our answer should also have 3 significant figures in it. Let's go ahead and take a look at the next example. It is asking how many grams are in 2.33 moles of water if 1 mole is equal to 18.02 grams. Starting off with the number that is provided is 2.33 moles of our H2O. Setting this up, we have the moles of H2O on top, so we know we're going to have moles of our H2O on the diagonal. Looking at the provided conversion, this will be 1 mole, which is going to be equal to our 18.02 grams. And we're able to solve. We're going to multiply the top, divide the bottom. In this case, whenever we divide by 1, the number will be the same. Keeping the number of significant figures the same, our 2.33 is 3 significant figures, so the answer will be 3 significant figures as well, which comes out to 42.0 grams of H2O. Now, as in everything we go through this process, it is important to remember that this is going to be a stepped process. So a little bit later in chemistry, what we're going to be end up doing is that we're going to be actually figuring out how to find this 1 mole being equal to 18.02 grams. Let's go ahead and take a look at the next example. It's asking how many seconds are there in 24 hours? So we have our 24 hours. Now we have hours on top, so we know that we're going to have hours on the diagonal. Going from hours to minutes will be the easiest conversion. So within 1 hour, there is going to be 60 minutes. Now that we're in minutes, we're able to convert over to seconds. So we have minutes on the diagonal that will cancel out. 1 minute will be equal to 60 seconds. And then we're able to solve. We're going to multiply everything on top, multiply everything on the bottom, and divide. In this case, with the ones being on the bottom, we're just going to end up dividing by 1. So we get 24 times 60 to be 86,000 seconds as the answer. Let's go ahead and take a look at our next example. We're going to convert 1,650 squared inches to feet squared. Now, the squared does make a difference in our dimensional analysis whenever looking at the conversion factor. So we have 1,650 inches squared. Now, our dimensional analysis still applies. We have inches squared on top, so we need to have inches squared on the diagonal. Now, going from inches to feet, we should remember that our 12 inches is equal to 1 foot. Now, with the squared, our inches are squared, which also means that the number needs to be squared as well. So 12 squared will be 144, and we're going to write this as 144 inches squared is equal to 1 foot squared. Now, whenever we square 1, it's still just 1. So 1 times 1 being 1. Now, this is going to be the conversion that we use in this step. We have 144 inches squared equal to 1 foot squared. And then we're able to solve. And we're still just looking at the regular numbers. So we get 1,650 times 1, all divided by 144, which will end up being 11.5 feet squared. Let's go ahead and take a look at the last example. We want to go ahead and calculate the fuel efficiency in miles per gallon of a car in Europe that travels 10.0 kilometers per liter of gasoline. 1 gallon is going to be equal to 3.77 liters, and 1 mile will be equal to 1.61 kilometers. Now, taking a look, we have our 10.0 kilometers. Now, whenever we set this up, because of this per right here, okay, our per is saying kilometers per liter. So the liter is going to go underneath. And then from here, we're still using our conversion factor, but we're just going to take a look at one unit at a time. So we have kilometers on top. We need to have kilometers on the diagonal. From our conversion, it says that 1.61 kilometers will be equal to 1 mile. Now, if we kind of remember from the beginning of this video, it was talking about how dimensional analysis is designed for unit cancellation. So, thinking about our unit cancellation, we have our kilometers canceling out with the kilometers. So, we're left with a mile. And the same thing will apply with our liters. So, we have liters on the bottom, which means that we need to have liters on the top in order to cancel it out. So we're going to end up with our 3.77 liters equal to 1 gallon. And this and everything still ends up working out because the liters will cancel. And then if we really take a look at this, we will notice that we now have our miles per gallon. And that is exactly what we're trying to find. So now we're able to go ahead and solve. We're able to multiply the top, divide the bottom. So we get 10.0 times 3.77 divided by 1.61. And that will provide us 23.4 miles per gallon as the answer. Talking about metric prefixes, our metric prefixes really help us to better describe a large range of measurements, especially when we are talking about the metric system. Now, our prefixes can be used with all SI units. For example, the prefix kilo means 1,000, so 1 kilometer will be equal to 1,000 meters. And the same idea will apply with our smaller numbers too. For example, the prefix milli means 1,000th, so 1 millimeter is equal to 0.001 meters. Now, what is nice with the metric system is that it's all based off of 10. So whenever we go up a step, it is going to be through a power of 10. And so this allows us to have a really nice, neat whole number. Looking at just some of the different prefixes, we have our kilo, milli, micro, nano, and pico. Most of the time for us, we are going to be talking about milli and kilograms. Now, whenever we are talking about our atoms, that is going to get into the nano and pico range. So we have our symbol, kilo being our K, our milli being a lowercase m, and so forth. And then we have the corresponding numerical value in base units and the power of 10 equivalent. Now, as we go through these different examples, the power of 10 equivalent is going to be what is used for this. And these and everything are really going to be important, and they are going to really kind of show us what we need. Now, how we look at this is going to be looking at a base unit first. So I'm going to go ahead and take a look at our grams. So if we have grams and we're going to take a look at our milligrams, for example, how we would take a look at this conversion is going to be to the power of 10 equivalent. So we have our 10 to the negative 3, and the 10 to the negative 3, or the power of 10 equivalent, is going to be what our base unit is. So in this case, our base unit is grams. So 10 to the negative 3 grams will end up being equal to 1 milligram. And that's going to be how we take a look at this chart. So our power of 10 equivalent is going to be in terms of our base unit, and then that is going to be equal to 1 of whatever we're looking at. Let's go ahead and take a look at this example of 25 seconds to milliseconds. So we're looking at our 25 seconds, setting it up in our dimensional analysis. We have seconds on top, so that means that we need to have seconds on the diagonal. Now, our milli, if we go back and take a look, is going to be our 10 to the third. So this is going to be 10 to the negative 3 seconds equal to 1 millisecond. Plugging this in, we have 10 to the negative 3 seconds equal to our 1 millisecond. We are now in milliseconds, so we're able to solve. Multiply the top, divide the bottom. So 25 times 1 divided by 10 to the negative 3. And this will provide us 25,000 milliseconds. Let's take a look at the next example. We have 352 nanometers and we want to convert it to meters. Starting off with our 352 nanometers. Same idea applies with our dimensional analysis, nanometers on top, so we have nanometers on the diagonal. Now, if we take a look at our chart, nano is going to be 10 to the negative ninth. Now, remembering that 10 to the negative ninth is the power of, and in this case, it is a meter. So 10 to the negative ninth meters is equal to 1 nanometer. And we're able to plug that in. So we have 1 nanometer equal to 10 to the negative ninth meters. And we're able to solve. Multiply the top, divide the bottom. We end up with 3.52 times 10 to the negative 7th. And in this case, it will be our meters. Let's take a look at our next example. So we have 5.30 times 10 to the 14th nanograms, and we want to convert it to our kilograms. So we have our 5.30 times 10 to the 14th nanograms. We have our nanograms on top, so we have nanograms on the diagonal. Now, whenever we are going from like nanograms to a kilogram, going from a very small number to a really large number, we do have to stop at the base unit. So we have to stop at our grams. So this is going to be a two-step conversion that we have to take a look at. So first, we have our 10 to the negative ninth from our nanograms. So we're dealing with our grams. So our 10 to the negative ninth grams is equal to 1 nanogram. Plugging that in, now that we are in grams, we are now able to convert over to the kilograms. Again, grams on top, so grams on the diagonal. If we take a look at the conversion with this, is that it is 10 to the 3, or 10 to the third, in this case, grams, which is going to be equal to 1 kilogram. Plugging our numbers in, 10 to the third grams equal to 1 kilogram, and we're able to solve. We're going to multiply the top and divide the bottom. So 5.30 times 10 to the 14th times 10 to the negative ninth times 1, all divided by 10 to the third. And this will end up providing us 530 kilograms. Let's take a look at one more example. In this example, it says that in a swimming pool, a metric mile is 1,650 meters. How long is this in feet? So we have our 1,650 meters. We have our meters on top. So we know that we're going to have meters on the diagonal. And in this case, the conversion that it provides us is 2.54 centimeters. So we want to convert the meters over to centimeters. Our conversion for this is going to be 10 to the negative 2 meters is equal to 1 centimeter. So 10 to the negative 2 equal to 1 centimeter. Now that we're in centimeters, now we're able to convert it over to inches. Using the exact same process, centimeters on top, centimeters on the diagonal. We have our 2.54 centimeters equal to 1 inch. Now that we're in inches, it is a fairly easy conversion to go over to feet. Our inches are on top, so inches are on the diagonal. Converting our inches over to feet, we should know that our 12 inches are equal to 1 foot. Now that we're in feet, which is what it's asking us to find, we're able to solve. We're going to multiply the top, multiply the bottom, and then we're going to divide. Whenever we end up doing that, we end up with 5,413 feet as our answer. And that is going to be how we take a look at our metric prefixes.